Good morning. Good morning, everybody. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India. On this day, December 30th, 2021, Thursday, 3:50 a.m. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। आज दिसंबर 30, 2021, 3:50 सुबह के, और मैं आपके सामने हाजिर अपनी बात रखता हुआ सिविल फील्ड इंजीनियरिंग related to life, engineers, concrete, specifications and quality, contracts and disputes, and of course, foundation and route to solution lies in communication and coordination for work and for contracts, as well as for whatever solution is necessary. And here you can write to me if you are interested. If you have some contract issues, you can also write to me. How contract should be done, lump sum contract, and what should be quality mean. And if you have some disputes on contracts, you want solution, you can refer to me for consultancy. I have long experience on contracts. It's no advertisement, just my long experience. If you can get some benefit, some relief, and this is my professional competency certificate, that is International Professional Engineers, and it is Chartered Engineer, as well as this is fellow membership. As usual, I show to you, because introduction is very necessary before saying something, and this is no question of pride, it's a question of facts. And I believe in facts. Facts, and engineering is facts. And this I don't claim that these certificates solve every problem. These certificates only indicate identification of some person. And that's what I tell you, means this is my only achievement in life. I'm not very much advanced person. I'm not very well internationally reputed or nationally reputed. I'm a very small guy. And of course, why should I say big? I do not get any major awards in my life, but those do not count when quality comes into picture. When I talk of quality, I talk of soul of world, soul of products, quality in this country and quality elsewhere. We have to consider all that. In our country, everybody knows that quality is not as it should be. It's not seen, it's not experienced, and that's where problem lies in. In our country, I want to repeat, no, I don't want to repeat, to be very frank. I want to speak something that comes to my mind every day, and every day mind works differently. But quality remains same, level of quality remains same, you can't change it. Because life is like that, and quality can't be replaced by something else. Quality requires to be achieved at all levels, and if you can't achieve this, then I can't say that engineers are successful. Engineer, you may work in design, you work in planning, you work in quantification, you may work everywhere, anywhere, but remember, without good designs also, we can't do good designs as well. How can you do designs when you don't know quality? When you don't understand what is quality, how can you do the work? It's a point of concern. We can say big concern, point of big concern, and we cannot run away from that fact. Maybe we call ourselves, I'm a design engineer, I'm not interested in quality. Everybody can say that, but don't forget, design is respectable only until it is not implemented on site. It's very much respected because lot thoughts have undergone pre-state to your design is issued. And it's really very much appreciated that design is excellent. Design is taken care of every action on it, every force to come on it, and in all structures. It takes time, of course. Now it's a computer age. You have opportunity. Design has opportunity to be detailed out and tried many times in modeling. But real modeling works on site. We know there are factor of safeties we take into consideration. Factor of safety which people abuse actually. Those who do not understand meaning of design, those who don't care of durability of structures, those who don't know that this structure is very important for decades to come. They take it for granted and they think only let it go on as it is and no problem. We make money. It happens. I've talked to many people, I've dealt with many people when they come to me, and they used to come to me before also. And they ask me, just give us some idea or give us some layout. Don't worry about structural engineering. They simply say, don't worry about columns and beams, we'll take care of that. Our experts know that. And who are the experts? The experts are masons and carpenters, experienced of course. And they take care of that. So what to do? Means how to tell people, no, but of course everybody has a small house to construct. I don't say that they should go to structural engineering all the time. But you must get something reasonable, something well to do. And there's a convention, there's some, reputation. If somebody has done some structure, that person must repeat that everywhere, anywhere. They don't care about this. And that not caring about that leads to immense, damage to quality system. I've seen contractors, they call themselves builders. I've seen builders, they call themselves experts. And they do whatever they want to do. They don't care for movements, they don't care for shear force, they don't care for deflection, they don't care for sway. Well, this is all in engineering, but they do not know. They only know, oh, this size of column is good, we have standard shutters, we'll use them, repeat that. And they don't understand anything about what is concrete, how does it work, what's the future, what's quality, what's that, what's that. And you can't explain to them because people believe them. That's unfortunate. Common people in our country believe in what contractor says because contractor can convince them very well. They are very well communicators, very excellent communicators, excellent, outstanding communicator you can say. But engineers cannot explain to public because first of all, public remains distant from engineers. Public remain distant to lawyers, they don't remain distant to advocates, they don't remain distant to doctors, they don't remain distant to all other professionals except engineers and particularly civil engineers. They remain distant. Reason being that civil engineers are not called in common problems. Civil engineers are called once in life maybe, and that through architect in this country particularly. An architect, you can say, architect who is not an engineer in itself. Architect does not know anything about structural engineering except ABCD like we know in English language. It is a question here to be resolved. Now it's okay, you have to speak something very specific, talk to people, and that is important one. It's 4-5 degrees Celsius. I have been feeling cold. My legs are getting cold and I don't know what's happening here. What is this here? What is happening? I don't know. How to put it very correctly. Hold on, sir. I'm just coming. I'm feeling very cold. So I'm trying to wear in the jersey and jacket. And then I sit down. Okay. What is this? I could not wear it. How did it come out? Oh my God. What is this foolishness for me? I am foolish, yes. Wait, just a minute, let me hear it. 5 degrees. 5 degrees, oh my God. Oh really? Oh my God, what to do? Cold. I'm sitting now. Okay. Let me sit. Sorry again, the rain is very cold. 4-5 degrees in morning time. I'm talking to you. I'm not used to cold comfortably. So I say, we're saying about architects. I don't blame anybody here, but reference is a must. If you have to talk, you have to refer. Architect is very important professional. Indeed, we cannot say no. Architect is wonderful professional, I can say, but one should be professional and not encroacher. What law says, that is different. But what world says, what whole world says, and where does architect stand? We have to be a little careful in our understanding. We should not forget the difference between an architect and an engineer. That is particularly that engineer who deals in designs, and also that engineer who deals in construction. You see, designs of structures and designs of building, there are two different views. First is we have to set spaces. Spaces, how we want to use this area, how we want to use this space, and that mostly depends on common sense. You see, you need ventilation, you need good area, you need a system where you can comfortably circulate in your building, whatever sort of building it is, whatever use of building it is. And that's where planning comes into picture. And that planning in a proper way, to use that space in a proper way, in a professional way, in a comfortable way, we can call that activity as architecture design. Nobody minds that. And when architecture designs comes into play, it doesn't mean that only architect can do it. Very you can say excellent structures were designed in past, in ancient times, when there was no degree of architecture. In fact, architecture is based on your own will. Of course, there's a training and degree, and there are various points which are considered. I'm not going to that. But point is, if you know what you have to do, a small house, a medium class house, where you know you can do your way, how I want to live, how many meters front, sides or rear we have to live, that is decided by authorities in particularly regulated areas. And in private areas, villages for example, there is no such regulation applicable, so they just cover whole area and leave some open in middle itself and center of that, which we call Haveli type, like that. Well, my deliberation is on difference. You see, now in current age, structural work is very important. It amounts to top level of importance, and this fact cannot be denied. In a building which you live in, if that building works safe, if that building leads you all time to be safe, and that's called sound building. It should be safe from residents' point of view. It should be safe from health and safety point of view. It should be, you can say, sound in its performance. You should not worry when there is a calamity like, thunderstorm, calamity like earthquake, or whatever kind of calamity that can be contained, and you can enjoy your structure. Structure means anatomy of a building. Generally we call in theory of structure formation mechanism. A mechanism of structure or through structure that accepts, that allows all actions to come onto that building, all forces to be imposed onto that building, go to soil through that structure. That is the only purpose of structure. Safely, serviceability, durability, and all points are considered in that. Safety is very important. Safety means safety of structure first and then safety of people. If the structure remains intact, the structure remains durable, sound, strong, resistant. Of course, it shall not collapse or it shall not distress. And purpose of it to transfer whatever load is imposed on it, including that load, it continuously goes on to soil below. It doesn't take any load permanently. It transfers load permanently, we know that. It may be wind load, seismic forces, thermal effect, whatever it is. Material is impacted upon. Whatever material we have included on that structure and building, it is impacted upon in long term. It loses sometimes its property that is named as hysteresis, and we call hysteresis loss. Hysteresis means today there is some stress some material can take, but it doesn't mean that it shall take same stress forever. There can be degradation in that strength, say in 30 years, 40 years, 50 years. It may come down to 80%, 70%, 60%. And that loss we cannot retrofit until we have to think of other way. We can reduce load on that, or we can change land use or cover use of that area. So there's a different consideration, and that we generally call in engineering hysteresis loss. So we can say hysteresis loss does not come to zero, just like it happens in materials, natural materials, elements, that it comes to some level where because half-life of material has come and we can't rely on this. So you can say half-life of structure. There could be some consideration like that, but there's no such as such. But we can common sense say, because I have to use this structure for coming 50 to 100 years, it should be strong enough, durable enough for that. Later on, we will demolish it and do it again. That's all we can say after 50 to 100 years. And generally, every plant we have in world over, facilities plant, processing plant, they are all designed for a period of 30 years. At start, they can be retrofitted, the technology goes on, and we don't need another design. It goes on like that. A building is generally designed, ordinary building, for example, where there is no structural steel, there is no structural concrete. It can be said to be only 30 years, 40 years, and then you can say distress comes on automatically because of rain, because of settlement, because of whatever reason. And we can say you can't trust that building anymore until you retrofit it. Same applies to every structure, because structure is connected to soil. And it is soil ultimately that is a structural material. It's not building. Building is a transfer arrangement, nothing else. Means you are going to transfer something to soil through that structure. So structural engineering is, you can say, is a burden on soil. A structure cannot survive on itself. A structure survives if soil survives. And soil also doesn't take load, it transfers those to further below layers, and that's what is phenomenon, and that's what is philosophy, that's what is the contemplation behind science. Ultimately, this earth takes everything and relieves us of all issues, all problems. This point we have to understand that every structure, everything, every good rests on soil ultimately. Even if pollution material, polluted materials that are responsible for pollution, that are thrown on earth, in sea or in continents, and there is no other way, because it is ultimate destination. Every one of us has only one destination, and that is soil. Once one is dead, it is soil. Body itself becomes soil. It may be decomposed by graveyard, or it may be burnt, whatever. So we have to think about that. We have prime relation with soil, and we have got prime relation with structural components and structure itself, and we have secondary relation between prime relation and soil, and that is finishing items, that is decorating items, and that is non-load bearing structures. This means basic structure cannot be changed commonly. It's nonsense if you think I can change column or beam. People do it. Unknowingly they do it. In old buildings, I have seen that many collapses happen because of ignorance of structural knowledge. And even during construction itself, it happens that they don't know what's going to happen. Every contractor, every builder inserts some column somewhere or removes column without analyzing anything because it's not their job. It's very important point when I say quality. It doesn't mean quality of material only. It doesn't mean quality of structure only. It means quality of how you are going to work. Because no column or no beam can work independently. No slab can work independently. No foundation can work independently in frame world. In world where we say it is framing, when we say it is framing, we have to be very serious about. And that seriousness should be visible. That seriousness is not just, we cannot take any decision at random. Why to decide at random? We cannot decide at random. If you take random decision, we cannot say that this is engineering. This means there exists no seriousness. And seriousness means engineering. When I say seriousness, you should remember that engineering means, if you want to define seriousness, you can say it is engineering. But does it mean that your face should be impressive or not impressive? That's not seriousness. Seriousness doesn't mean I should sit down and condole. No, that's not seriousness. That is something else. That is condolence. I'm not here interested in condolence. I'm interested in seriousness. And that seriousness is that I should think on. I should think on why this problem has appeared. What is the reason behind that? Nobody would tell me. My own acts would tell me. My mistakes would tell me. And my past would tell me. My present issues would tell me. They will tell me one by one. If I don't sleep, if I don't drink, if I am in proper sound mind, I'm not hangovering, I'm not in hangover, and therefore we have to be very serious. Definition of engineering starts with seriousness, and that seriousness means controls. If you are serious, you can control whatever you want to control. If you are not serious, you cannot control even solutions. You will destroy solutions. If you are not serious, you shall destroy your money. You will not even think how to spend your money, and I have enough money, plenty of money, I don't care, I have no budget for this, I can spend whatever I buy. You'll go on spending your money and you see balance goes to minus. No, there is a calling that if you have full treasure, that treasure doesn't have permanent, it doesn't live permanently, and one time you say, oh, you are in liquidated stage. You are insolvent. That's why I say we have to be very careful. Quality is not quality control alone. Some people think, okay, don't worry about this, just see what problem is there. I'm not talking of quality control alone. Quality control is a part of quality, but quality system I'm talking of. Quality system must be sound, must be strong, must be durable, must be functionable, and must be reliable. If it's not reliable, there's no meaning, and you have to decide it. No one else will decide for you. It's like you decide your schedule, you decide your system yourself, you have to make system yourself. And we have various quality systems these days. But those are all dependent on experience. You have your own experience. You have to make sure whatever quality you work in, every act is quality act. Every act must have quality, even if it is, we don't even observe it, but it happens. Life has many aspects of quality. Same way in engineering, designs have many aspects of quality. Writing specifications has another aspect of quality. And working practically on site for physical production must have many aspects, many steps, many landings of quality. And it's not defined in one way. People say, I'm a designer, and nothing to do with quality. No, I don't agree with that. You are a designer, you are first person responsible for quality. You are a thinker of quality, you are a thinker of design, you are a research professional. Design means operation of research. And generally, design in engineering, structural design you can say, it's called a part of research, and that is named as operational research. Because you can try many designs many times for one structure, and then you have to select best design for that, which is economical, which is proficient, which is permanent, which is durable. That is basically required. And if you can't do that, then there's no meaning of design. It's something elementarily you can say. A student studies design foundation. You can say, I will design foundation, I will design column. A designer can't say that. This is last requirement. First requirement is you have to talk to your design first, which you propose. You have to talk to your proposal yourself. You have to raise questions yourself. And every designer does it. I'm not saying what it is. I'm just explaining it because people have to know. It's not for you alone. Yes, you are an engineer, you are well educated, you are well qualified, you are a competent person. You should show competence in your designs, and then design should competence in your execution. And that's a very important point. If execution is ultimate, you can say ultimate destination. Your design is hung at execution. It stands in hangar of execution. Design is your flight, design your aircraft. Maybe you think on that. You fly, your design flies in air, in space. And that design is transformed into air flight, aircraft. And that aircraft is hung if your design is hung. If your design is not stable, you have to park your aircraft into hangar for maintenance or for something else. Don't make your design hanging one. It should be walkable, it should be workable, and it should be friendly. It should be having highest degree of constructability. It should be easy, it should be comfortable, and it should emphasize, it should induce a person who works on site at every level an interest to read your drawings again and again and to think of how best you have done. That's what it says. It depends on each person. Nobody wants to do complicated work. Everybody wants to do good work, easy doing work. But easy doing does not mean easy design. And complicated design doesn't mean excellence, because it affects cost, it affects time, it affects internal as well as external architecture. And it depends on which design you are doing. Designs are designs. Construction is construction. System designer cannot say what is real design. You can try many systems, same way many designs can be tried, and only that design which performs in the best way and which is supported by people and which works for interest of public, I can say is a reliable one. And design means quality of design. In your mind, when you design, you should think you are working, not simply software assistant you are or software oriented you are. Software cannot give you any design. Design only your intuition can give you, your mind can give you, or for whoever seeks designs to be done by you, maybe architect or else. The already picture is clear, film is there in mind, and you have to create it on paper, and then it has to be created on sites. That's what sequence is. Just jumping onto conclusion, something else is not adequate. I have seen people, young engineers, talking of very elementary questions. Really, I sometimes get irritated. You have gone through degrees, masters, and then you raise certain questions which are not, matured questions, I can call it, not matured questions, childish questions, you can say. If you are not clear about fundamentals, if you're not clear about what is real design, or if you are not clear about ultimately who is receptive of these designs, constructions, that is soil layers, if you're not clear about those, I don't know in that case on what basis of integration of available information one can call oneself engineer of structures or structural engineers. Structural engineer, structural engineer is not meant for designs only, it is meant for proper execution also. I don't know why people in our country, Bharat, India, do not realize these facts, and even engineers don't understand this fact. I have seen many overseas engineers who work on sites and call themselves with pride, I'm a structural engineer. I have seen that. They visit sites, and if site is mega one, they stay there. And they work on structures. They define what is a structure, they provide information, they provide working drawings, and if required, they design also. They do their designs, and then design is worked in field, and they check every activity of design. A structure engineer goes to site and inspects. I don't know, here it doesn't happen. If you are MTech, you think you are a designer. If you are PhD, you think you are a design engineer. That is your thought. I am not talking only of designs. In structural engineering, design of structure as well as execution of structure, both are equated to structural engineering. We know only incomplete definition, that is our problem. We want to keep ourselves off sites. Every structural engineer has a right, has a duty, has a responsibility to be present on site when given opportunity. And our contractors, our builders, our promoters, our people must understand this point. Quality cannot be achieved otherwise. When I talk of quality, I talk of all these issues. I am not defining here what is quality. Quality is at every level. Macro level, micro level you can say. Project site level and project design level you can say. Procurement level you can say. Planning level you can say. At every level it works. And we do not realize this fact, and that's why we suffer. And this suffering should go. That's the reason I'm talking of quality in language Hindi as well as in English, because it is engineers who are responsible for this quality. It's not contractor, it's not promoter, it's not someone else, anyone else. It is only engineer who is responsible for works. It is different whether or not these are employed. I'm not talking of that. But on an overall basis throughout world, engineers are considered responsible and not managers and not others. It is simply saying that engineer is engineer. Engineer can make good manager. Engineer can make good administrator. But administrator cannot make good engineer, and also manager cannot make good engineer. That is very clear. One engineer, experienced one, can be excellent manager, can be dynamic manager, can be administrator, can be whatever it is, but if seriousness exists. I don't know why seriousness doesn't work in people. I don't know why culture of our people is different. It should not be. We are very smart people, very dynamic people, and we should know this fact. Don't take it that I am criticizing engineering community. I am not criticizing anyone. I am trying to bring them to a track that they have lost. And that's a fact that engineers have lost one track. And that track is follow-up of quality, creating quality, showing quality, and not simply certification. I do not write behind my name, I have so many degrees. No use. My degree is proved by my work. If I cannot prove that, I always raise questions. This means I am incomplete. I have to solve questions after working. And it is unfortunate that current engineering people, engineering professionals, they don't want to work in sun. They don't want to work on sites. Until you work on sites, you cannot know facts. That's also true. And engineers should know economy also. Engineers should know budget also. At least you should know if you don't practice. Just checking one item is not enough for calling engineer. If somebody says, go and check steel reinforcement, don't worry about billing, don't worry about something else. No, it's not enough. I'm not saying you get expertise, but just depending on steel and not understanding what is concrete, how does it work, how does it work, how is poured, then I think you are incomplete in your status. You should know everything about your material that you are going to include in designs. You should even tell everyone in writing statement what you have to do, what we think we have to do, and based on that intention we have done this design. That must be seen, but unfortunately this doesn't happen. That's where I can say that we have to change somewhere. I was talking about concrete in my specifications, actually not my specification, it is some Qatar specific. Say precast concrete we talked of, and I actually forget which page it was, so I don't know which page it was. Polyester is in concrete we had gone through, so no need. So structural concrete is talking. In this scope, I talked of work included section comprises furnishing all plants, workers, equipment, appliances, and materials and performing all operations in connection with structural precast concrete work. And of course, we can say manufacturer's literature. Contractor shall provide copies of manufacturer's specifications and installation instructions for each item of proprietary material to be used. That's also an important point, I'm just blowing it. The work includes in this section encompasses furnishing all plants, equipment, workers, equipment, and appliances, materials, and performing all operations in connection with structural precast concrete work. And related part in this specifications are aggregates, cementitious material, admixtures property, requirements, concrete plants, transportation and placing of concrete, formwork, flooring, reinforcement, hot weather concreting, and there are standard specifications for highway bridges, section 25, guide for precast cellular concrete floor, roof and wall units, guide for precast concrete wall panels, design responsibility for architectural precast projects, and you can say precast concrete projects, design, manufacture, and installation of concrete piles, guide to emulating cast in place detailing for seismic designs of precast concrete structures, minimum design codes for buildings and other structures, building code requirements for structural concrete, structural use of concrete, Eurocode 1 actions on structures, general actions, wind actions, Eurocode 2 designs of concrete structures, general rules and rules of buildings, Quality Organization Management System, fundamental vocabulary, and Precast Institute, Precast Concrete Institute manual. And then we have to submit to the manufacturer's literature. We have to say contractor provide copies of manufacturer's specifications and installation instructions for each item of proprietary material to be used showing compliance with this specification. Information on equipment, embedded items and other accessories shall also be provided. Design mixes, copies of mixed designs with support material. Requirements of mixed design shall be in accordance with part 6 and 7 of this section, as we have said. Product design criteria. Loadings for design, initial handling and erection stresses, all dead and live loads specified on contract drawings or as required, all other loads or forces specified for member where they are applicable, product design calculations. Design calculations be performed by structural engineer experienced in precast concrete design, shall cover all stages of handling, transportation and erection. Design shall be carried out in accordance with the requirements of BSEN 1992-1-1 or relevant ACI codes and be accepted by engineer. Calculations for design of precast members shall be supported by a statement explaining the principle of design and types of analysis adopted. Influence of individual members in achieving overall stability of structure should be considered. Computer programs used in design shall be fully described, and details of input and printout shall be presented in a manner which can be readily understood, and following requirements shall be met. Program manuals and instructions to program users shall be made available to engineer upon request. Where such program cannot be demonstrated by contractor, they have been fully checked or where engineer considers it necessary. Contractor shall run such test examples as engineer may choose in order to verify completeness and accuracy of program. Members that are exposed to weather shall be designed to provide for movement of components without damage, failure of joint seals, undue stress on fasteners, or other detrimental effects. When subject to seasonal or cyclic day or night temperature ranges, precast system be designed to accommodate construction tolerances, deflection of other building structural members, and clearance of intended openings. Calculate structural properties of framing members in accordance with BS 8110 or BSEN 1992-1-1 or relevant ACI codes. Shop drawings. Contractor shall provide following information for approval of engineer: layout plans and detailed fabrication and placement drawings for each structural precast element. Shop drawings are to include following information: size, grade, profile, and dimensions of all materials used, connection and anchorage details, lifting devices, locations and handling limitations, steel reinforcement details, all opening sleeves, inserts, and other provisions in full coordination with all trades in contract, identification marks, erection procedure, detailed outline of sequence and method of erection, including but not limited to types, capacities, and numbers of craneage, method of support and transportation. Fabrication records. A record shall be kept for every piece of precast element produced showing following type and number, date of pour, concrete test results, shop drawing, reference number, type and duration of curing, date of delivery to site, date of fixing in position, test reports, copies of all testing and inspection reports, trial panels. Contractor shall produce trial panels in accordance with requirements of Part 10 of this section. Trial panel shall be retained for reference purposes for acceptance of production work. Qualifications. Structural precast work shall be executed by an approved specialist subcontractor for casting and also for transportation, handling, and erection. Contractor may execute this work self if he can satisfy engineer that it has sufficient experience and expertise in this field. Minimum contractor shall provide satisfactory evidence that its tradespersons and its supervisory personnel engaged in such work have a successful experience with work comparable to that shown on specified. Provide details of organized quality control and testing procedures. Quality requirement. Precast concrete supplier shall have a quality requirement scheme performed to secure for project homogeneous concrete having required strength, surface finish, materials, durability, and weathering resistance, without planes of weakness or other structural defects, and free of honeycombs, air pockets, voids, projections, offset of plane, and other defacements of concrete. No alterations or substitutions of structural systems shown on drawing are permitted unless otherwise specified. Contractor shall supervise and coordinate all phases of structural precast concrete construction process and be responsible for complete manufacturing process. All methods of manufacture and practices of handling raw materials and manufactured concrete shall be reviewed by engineer before execution of structural precast concrete work, at least 14 days before beginning of precasting work. Only materials of known quality shall be incorporated in work. All materials shall be properly selected, reviewed and approved by engineer before use and maintained during shipment, storage and use. Construction systems and techniques shall be properly selected, reviewed and approved by engineer before use and maintained throughout complete structural precast concrete construction phase. Adequate spare equipment parts, additional components and repair facilities shall be available for all tools and equipment. Regardless of approvals by engineer, contractor shall be held responsible for all materials and methods of structural precast concrete work. If work doesn't meet specified requirements, contractor shall at no additional cost to employer implement removal, replacement or remedial works. Revise procedures for materials to prevent the recurrence of unacceptable work. Quality issues, quality controls. Contractor shall prepare and provide its quality control program for structural precast concrete work with particular attention to details, pre-checking processes, procedures and close supervision. And in particular, contractor shall, in order to assure that proper work is performed, to prevent later corrective actions, assign at least one experienced supervisor, full-time or dedicated to provide quality control requirements for structural precast concrete work. Assignment shall not relieve contractors, other quality issues or control personnel of their duties and responsibilities related to quality issues, controls of structural requirements and surface finish of structural precast concrete work. Contractor shall arrange for training of its quality control personnel who perform quality control of structural precast concrete work and whose training include but not be limited to material evaluation, spatial mix design techniques, mix placement, vibrator selection and use, formwork details, formwork protection, release agent use, reinforcing steel, detailing and installation, finishing equipment and techniques, corrective procedures and protection of completed work. Contractor quality control personnel shall be responsible for verifying all details necessary to produce final structural design objectives. Contractors quality control personnel shall also verify quality of structural precast concrete work and guide production of results which ordinary, but ordinary except that it is done in industry or in factory. Testing is very common. Concrete shall be tested as specified in this section, in part 6 or whatever. Contract shall furnish workers required to facilitate testing. That is, of course, you may say specifically trained workers. Inform engineer with at least 1 day. Inform engineer with at least 1 day's advance notice when concrete is to be placed. Provide storage facilities for concrete test cubes. Provide material samples and access to materials as required for testing. Should batching plant be located more than 500 meters away from site office, contractor provide suitable transport acceptable to engineer for sole use of engineer's staff. Contractor shall station a qualified technician at casting site to continuously test, inspect, and report on following requirements. The concrete testing is being carried out in accordance with requirements of Part 6 of this section. Check following and verify conformance with specified requirements and approved shop drawings, and that is reinforcing bars, all embedded items, all formwork. Check all openings and provisions for coordination with all trades in contract as shown on approved shop drawings. Contractor shall provide facilities and equipment for conducting of all tests specified herein except for strength test and handling. Structural precast elements shall be removed from form without damaging or overstressing, and of course stored or placed for transportation on a stable bed that shall not allow distortion of member. Generally these are transported using trailers, low-level trailers. Separate stacked member with suitable battens and bracing. Separate stacked members with suitable battens and bracing. Mark each member with an identifying reference or piece mark and date of casting. All piece marks are to be correlated with test reports and plan layouts or erection drawings. A structural precast element be transported with sufficient battens, bracings and supports so as to prevent overstress by vibration or impact loading. Contractor shall submit its proposed method of transportation to engineer for approval. Structural precast units shall be stored, handled and transported in a manner that would avoid undue strains, hair cracks, staining or other damage. Contractor shall deliver units from casting site to project site in accordance with schedule and proper setting sequence. Structural precast units shall be stored free of ground and protected from wind or rain splashes. Units shall be covered and protected from dust, dirt or other staining materials. During fabrication, construction and after erection, contractor shall protect castings to avoid possibility of damage. Design, loadings, actions and structural member selection. I think we've gone through fast speech, better for everyone understand what is that. Signals are always questions here. I'm interested in just giving as much possible in shortest time because this specification of concrete I understand is important one for every engineer and also those engineers who work overseas because people least concentrate on specifications like concrete one. They want to do conventional activities and which is just not going to work in a way it should be because concrete technology keeps on changing very fast and we have to keep update. I'll come back to design, just I'm trying to explain something which is very important because I remember all my history of work, my career. When I started, we did not use all these test controls. These test controls were available, but details were not available to that level. And in India, in Bharat, we used to say, okay, just take some box and measure this concrete. Volume C, measure this, you use this box, timber box. As you know, site measurements we used to do. And that was controlled quality. We used to consider that as quality one. And that was a very important point where you say, okay, this is a box equivalent to one cement bag volume. You can measure it, so now we have to get quality control on 1 to 4 concrete, where 1 is cement, 2 is sand, and 4 is aggregate. Use this box and say one box, one cement bag, 2 boxes of fine sand, or you can say fine aggregate, and 4 boxes of aggregate, coarse aggregate, and mix accordingly. That was limited quality control, volumetric basis, but world rapidly changed after that, and we have to rely upon weight ratio, weight measurement, and then added upon that came up water cement controls, and also temperature controls, air controls, and you may see many more controls. Slump tests on sites is a very preliminary test, which was of course in some time when OPC was used in concrete. No GGBS, no PFA, nothing in those days. Nobody knew what was PFA and what was GGBS when I worked in 1981, or we worked in before, you can say somewhere in 75 to 80 in Delhi. There was no such question, no such specification, and we simply used to say in those days, that we have to work according to CPWD specifications, and with CPWD I mean to say government department, which considers itself standard 1, and we just used to certify on our works that these works have been carried out and manufactured, have been done according to CPWD specifications, and that was final answer. But now that time has gone. You can say in these 3 decades or 4 decades, heavy changes, considerable changes have been impacted, have been produced, have been included on concrete. And concrete is not simply a material now. Concrete is not only a material now, it has become a kind of institution of concrete. So much so has joined concrete that, it's in itself major discipline, major subject. If you compare structural steel and structural concrete, you'll find vast difference. Designs of engineering, designs of civil engineering, or you can say structural engineering, are complete different world, and you have to use your imaginations. And these imaginations, these designs are worth for doing. But for doing it, for implementation of designs, for execution of these designs, we must have capability. That capability is available in many countries. We too have that. But only problem is no will. And when we say there is a will, there is a way, also reverse is true. When there is no will, there is no way. And when there is no way, means it is no way. I stress on quality because of these reasons. Concrete item is exclusively important and expensive. And it is such an item, it is such a work that it's at initial stage becomes permanent. You buy a car, it may be with you, it may not be with you. You may like it, you may like it, you can dispose it. You can dispose concrete also to someone else, but question remains same. Service of a car can be done. Parts of a car can be replaced. Even engine can be replaced. You can change, you can modify, but structure doesn't appeal that. It doesn't appeal that way. It doesn't fit it that way. There is no way that structure can be handled like that. No one can handle structure that way. Structure is like earth. Because it is connected to earth, you have to demolish it if you want to change it. And if you have to demolish it, that means wastage of natural materials. And that is against environment. Therefore, it is of utmost importance that structure should be considered as destination forever. Until we keep that in mind, we can never understand engineering. Until structural engineers and civil engineers do not realize this fact, they cannot be perfect at every point. And even architects, they have to realize this fact. Because architect is always secondary. It is not preliminary, it is not primary. Without structure, no architecture can exist. Even it is brick structure or it is stone structure, architect exists only because of that. If architect does not realize this fact, then it is not exclusively architect, but you can say artist. Artist of fine art, or you can say artist of isometric, artist of a scene, not architectural engineer. Architect includes engineer and engineer includes architect both. Because architect thinks of some imagination, thinks of some dream and produces that on paper. But engineer thinks of structure and that structure itself exposes architecture. You can say created architecture and thoughtful architecture, both are there. And every structure is a combination of both. Because line work can be thought of, spaces can be thought of, but projections of structures cannot be thought of. That is difficult at time of designs. And this privilege goes to structural engineers and civil engineers. They are privileged in this way. Architect is privileged in different way. Basic job of architect is space, design. And basic job of engineer is to structural design and structural implementation. I keep both places structural engineers because alone civil engineer cannot do structural engineering until civil engineer is a structural engineer as well. May not be 100%, but 50%, 40%. We cannot simply say I am checking sol, I am checking plumb, I am checking dimension. That's not simple answer. I am going to check structure. That should be answer. Formwork checking, steel item checking, these are structural items. We cannot simply disregard this fact. Oh, this is site job, site person has to do it. But site person who is going to work on structure must understand structure. It's not check of lines or check of verticality or check of angle or check of steel bar length. No, it is a structural component. It's checking every part of body of that structure, that anatomy that you are going to do. We have to try, we have to understand this fact. Every batch of concrete is important. Every bar of steel is important. Every level of shuttering is important. Every line of column and beam is important. We have to understand this fact. We cannot live simply on saying, okay, go to site, check some steel, come back. This is not structural inspection. This is just visit. I'm not interested in visit. I'm interested in details checking and establish that I've done it. I have no right to certify that work has been done according to contract requirement or technical requirement until I involve myself or somebody should involve, and I should rely upon that. That's where point lies in. I'm not very highly qualified engineer, to be very frank. I'm an ordinary qualified engineer. You can say ordinary bachelor. You may be highly qualified. Maybe 70 or 80% of you people are postgraduates, or maybe 10% of people are doctors. That is honorable. That is regardable. I regard you because of that, because I am not that. I am very low profile, very ordinary person, but I respect work. I don't say that I would work only on software. My career has been a multiplex, you can say. I used to design sometime, many times, using first principles, which people forget now. Because people have become slaves to software, not leaders to software. Software should be slave, but it has been reversed. People have been oriented only on software, and that is where you can say basics, designs have gone. Even people are not sure of their results, what results they get. They don't have confidence in that. They raise questions to seniors. I see these questions every time when I open certain websites like SAFE. You find questions which are not worth an engineer should ask. Means there has been deficiency in your education. And because you directly claim I am this, I am a structural engineer, still today I cannot say I am an engineer, to be very frank. I started my diploma, then I passed it in 1974, and then I passed my degree in 1980. So I started my part career or part engineer career from 75 onwards, and from 1975 to 1980 I was part engineer, or you can say para engineer, and I got my final degree in 1980. And from 1980 onwards, you can say 1980 onwards, 1981 onwards, 20 years and 20 years in this century, we can say that it is 40 years around. Still today I don't consider that I am a complete engineer. Yes, I am, you can say, a small, experienced engineer, and I feel happy, really speaking, I feel happy that I got field experience, site experience, partly design experience, partly quantity experience, partly planning experience, partly construction experience, partly safety experience, partly communication experience, partly coordination experience, when dispute resolution experience. And I feel that I have some wealth with me based on my experience. I'm not claiming I'm expert of these, because no one can be expert of anything. It's all imagination. It's only to keep yourself happy. But only wealth is when you deliver good engineering, that is wealth. How much salary you are getting is different. I'm not concerned with that. Because salary is commercial work. It is commerce. We are not doing commerce, we are doing engineering. Of course, engineering is related to commerce, but when you do engineering, you cannot keep point of commerce in your mind, because it distracts you, detracts you from real work. Of course, commercial is very important from contract viewpoint, from business viewpoint, from every point of view, but you cannot cross quality of your actions, quality of materials, and quality of your approach. And that's what we say. We say knowledge areas. Whatever knowledge areas are included in organizational management, like quality, cost, time, and all other resources, whichever we are going to use, we include, we depend on them. Quality is involved everywhere. What sort of thinking you are doing, you are busy in, you are contemplating, that also imports quality. So again I say, quality of concrete and quality of work, quality of actions, quality of approach, quality of seriousness, everywhere you can use this word. It is kala, you can say kala, quality. I am not just talking, I say it's reality. If we understand quality, we have to revisit quality, in fact. Requirement is that. We have to revisit quality. Otherwise, we cannot understand what is quality, how it works. We will assume only we have done with quality, but we won't be recognized world over. Engineering is world over recognized. It's not Indian engineering or Bharat engineering or USA engineering. It is engineering for everybody. Without engineering, world cannot move. Engineering is universal. It is worldwide, just like medical science is worldwide. Law is not worldwide. Chartered accountancy may not be worldwide, but engineering and particularly civil engineering is worldwide. Because civil engineering is raw engineering, it is material based engineering, it is not machine based engineering. There will be many designs of machines and patented, but engineering design, civil engineering design cannot be patented because every design is different. You cannot repeat design. One cannot repeat design. You may repeat architecture, but structural designs can't be repeated because of many reasons. Local issues, what is national parameters, what is international parameters, what are international parameters, what is nature of soil, nature of environment. All these are varying, they all vary from one place to another place. Therefore, those who work in civil engineering, they are fortunate too from this viewpoint, not from salary point of view. But remember, time is going to come because people are leaving civil engineering. They are not interested in civil engineering because, first of all, how to sacrifice, why to sacrifice. Civil engineer means sacrificer. You cannot be a civil engineer if you say, no, I am only design engineer. Then I will not call you civil engineer because you are not civil engineer. You are only design engineer. You are not even a structural engineer, I would say. A structural engineer equal to design engineer plus work engineer plus civil engineer, everyone. A person who delivers designs and works on designs on sites, that person is called professional engineer. Just saying I'm expert in designs, you are experts in nothing. In fact, I say you are not a professional, maybe part professional. If you can't implement your design, or if somebody else cannot implement your design with full constructability, I would not define you, I would not entitle you as a structural engineer. You see yourself, you face problems yourself, you learn from them, and then implement, and then do design based on your experience. You shall become a structural engineer. International definition of structural engineer is that it's not simply sitting in office and doing designs only and claiming I'm a structural engineer. There is no qualification in degrees that can claim that you are a structural engineer, even if you are MTech or if you are a doctorate. No, it is not. Your experience is more than required. Your experience is above all other criteria, defined criteria. Experience is valuable. It can be measured, it can be weighed. Then a few years of degree. I have seen people who don't have any degrees in engineering. They learned through experience, matured people, which are used to be called matured path of engineers. I have seen many cases myself. They are excellent structural engineers without having any formal degree. But they have trainings and they are well licensed. Structural engineering based on maturity, they work, they learn, and they go to study theory also at that time, and then they are qualified by examinations, not ordinary qualifications. A person who works in field and studies in parallel can result in better engineer. If you take example of institution of engineers who used to conduct section A and section B of graduation, their own graduation, that was part of section A and section B examination, post diploma or post graduation science graduation. These engineering students were of course intelligent. There might be some economical reasons or some lapse in education reason at school level that did not allow them admission. But you have seen there are now lakhs of such engineers who have come out of that stream of non-formal education, and they had led profession. They have gone to that level where degrees don't matter, but personality matters, work matters. Some people used to call They are oriented for sites. No, I won't say that. Site or office, site or designs. It depends on your interest. How many degrees you want to count in, you want to earn, that depends on interest. But remember, whatever time we spend on education, it's excellent one, it's good one, it's useful one. But same time, if you spend on works based on engineering, you also get a lot. Maybe it is not described in our country, but I have seen many people, many professionals who have been registered as Doctor of Engineering. In UK particularly, Doctor of Engineering, because not only because not of it's not because of their engineering degrees, but because of engineering experience. They can perform much better than doctors can perform, and they know everything about construction and construction designs. And I like that approach because it involves practical aspect. It involves reality of life. It is not simply gossipism. No, it's fact of life. So I was talking about design loadings, actions, and structural member selection. I just wanted to divert something so that we understand facts. Provisions of this clause shall apply if contractor is responsible for designs of structural precast units. Precast elements shall be designed to withstand all loading conditions against which strength and serviceability must be measured. Vertical loads shall include self-weight of precast elements, floor coverings, and live loads as indicated on contract drawings. Wind loads shall be calculated based on wind speed provided in section 1 part 1. Okay, account shall be taken of loads and deformation caused by temperature and time dependent deformations. For such purpose, 55 degrees temperature, 55 degrees Celsius temperature variation, and 90% relative humidity should be considered for all members. So what it says important here, this is too important. Account shall be taken of loads and deformations. Deformations which are caused by temperature and time dependent deformations. For this purpose, 55 degrees temperature, Celsius temperature, 55 degrees Celsius temperature variation, and 90% relative humidity should be considered for all members except exterior elements, and facade element shall consider 85 degrees Celsius. Very important point here. This is given. Precast elements shall be designed in accordance with BSEN 1992-1-1 or relevant ACI code. Design tensile stresses should not exceed design flexure and tensile stress of concrete at particular age of concrete. Nominal cover to steel including links must meet durability requirement of severe condition of exposure and to meet requirement of 2-hour period of fire resistance, 2-hour period of fire resistance as provided for in BSEN 1992-1-1 or relevant ACI code. Total deflection of precast elements should be limited to 1/350 of span of this element, 1/350. Plan and design for openings for building services where required or necessary. Materials. General. Contractor shall obtain cement, aggregate and water from a single source sufficient to complete entire structural precast concrete. Cement from one source, aggregate from one source and water from one source. Sufficient to complete entire structural precast concrete work to assure regularity of appearance and uniformity of color. Contractor shall provide all materials in accordance with and meet all applicable requirements of this section. Reinforcing bars shall conform to requirement of part 11 of this section. You can refer to that one. Bearing pads, elastomeric neoprene, conforming to AS2, standard specifications for highway bridges with following stipulations. Use unfactored loads for design. Maximum compressive stress 0.7 MPa, maximum shear stress 0.07 MPa, maximum shear deformation half thickness. 1/2 thickness, maximum compressive strain 15%. Embedded steel, all embedded steel shall be stainless steel grade 316L, forming general. Forms and casting beds are to be firmly seated. Forms and casting beds are to be firmly seated so as not to deflect or be displaced under concreting or tensing. And we can say forms and casting beds are to be firmly seated so as not to deflect or be displaced under concreting or tensioning loads. Again, 0 videos and audios, and that's the problem lies in, Well, concrete for thermally induced strains or forces. You can say for members penetrations larger than 150 mm. For members penetrations larger than 150 mm, coring or field cutting is not permitted unless approved by engineer. Clean and coat forms with release agents before installation or reinforcing or embedments. Tolerances. Permissible deviations or formed surfaces are not to exceed tolerances outlined in PCI manual, and these are here dimensions plus minus 5 mm, width plus minus 3 mm, thickness plus minus 3 mm, flange plus minus 2 mm, embedment with penetration extent plus minus 0.2%, straightness plus minus 3 mm for 300 centimeter, and squareness plus minus 3 mm. Installation. Contractor's erection responsibilities include safe and proper placing, aligning and leveling of structural precast elements on accepted bearing surfaces and affecting their proper fastenings. Before placement of structural precast elements, contractor shall conduct survey and maintain all temporary supports shown or required to control alignment and deflection. Temporary support shall be retained until framing elements based thereby have attained integral stability in accordance with design. I repeat, temporary support shall be retained until framing elements braced thereby have attained integral stability in accordance with design. Guying, bracing and shoring. Contractor shall install in proper sequence and maintain all temporary supports shown or required to control alignment, deflection and stress level. Temporary support shall be retained until framing elements braced thereby have attained integral stability in accordance with design. Adjustments and correction. Contractor shall compensate and correct for misaligning, effect of temperature draw from welding, bolting or erection sequence or grouting. Erection tolerance. Following erection tolerances apply unless otherwise specified in contract. Variation plumb 1-in-1, you can say 6 mm in 6 meter run, 12 mm total in a 12 meter or longer run. Variation from level or elevation 6 mm in runs, 12 mm in 12 meters run, maximum 12 mm. at single location, and this is elevation. Variation from position in plan plus minus 12 mm maximum. Offsets in alignment of adjacent members at joints. Offsets in alignment of adjacent members at joints 1.5 mm in 3 meter run, 6 mm maximum, and welding. Welding where permission for welding is given by engineer, following shall apply. Welding shall not affect until all adjacent elements to be connected have been aligned, firmly seated and braced. Control of heat buildup by limiting voltage, electrode size and rate. Spalled or heat damaged concrete around weldment shall not be accepted. Ground. Joints, grouting, joints, gaps, joints and connections shall be filled with grout as shown on drawings and as approved by engineer. Field cutting of holes may be done only with engineer's concurrence and only with power saws or core drills. Steel reinforcement or pre-stressing strand shall be avoided. Where reinforcement of strand is damaged, unit shall be repaired to satisfaction of engineer or rejected. Maximum hole size shall be 150 mm diameter or as limited by member size or stand location. Cracks, spalls and sharp corners created by field cutting are to be ground, eased and patched with epoxy type bonding and patching compounds. Pre-stressed concrete. Pre-stressed concrete, in which we have here general scope references, submittals, storage and handling. This is as usual, we can say. In pre-stressing, general wires and strands, sheaths, cores and ducts, anchorages, jacking equipment, tensioning, grouting, grout mixture, grout trails, and we can say here pre-stressed concrete. In this scope describes requirements for pre-stressed post-tension concrete, including materials and procedures for installation, stressing and grouting. And it relates to many sections: aggregates, cementitious material, water, admixtures, property requirements, concrete plants, transportation and placing of concrete, recommendations for designing pre-stressed concrete pavements, analysis and design of reinforced concrete bridges structures, seismic designs of liquid containing concrete structures, analysis and designs of reinforced and pre-stressed concrete guideway structures, designs and construction of circular wire and strand wrapped pre-stressed concrete structures, design and construction of circular pre-stressed concrete structures with circumferential tendons, recommendations for concrete members pre-stressed with unbonded tendons, standard specifications for steel wire deformed stress relieved or relaxation for pre-stressed concrete railroad ties, standard specifications for filled epoxy coated 7-wire pre-stressing steel stand, standard specifications for zinc coated carbon steel wire, standard specifications for steel stand coated 7-wire for pre-stressed concrete, wire and stand wound, circular pre-stressed concrete water tanks, testing low concrete, testing fresh concrete, testing hardened concrete, specification for high tensile steel wire, and stand for pre-stressing concrete, Eurocode to design of concrete structures and testing of concrete. Now we are talking in these samples, 1 meter, a 1 meter length sample of stand shall be taken for every 1000 meter of stand. 1 meter from every 1000 meter or 1 kilometer. 1 meter length sample of stand shall be taken from every 1000 meter of stand. to be installed in works and with a minimum of one sample of strength per reel on site in presence of engineer. Strength test at independent laboratory approved by engineer. A reel shall only be accepted if both breaking load and 0.1% proof load of sample exceeds characteristic load given in BS 5896 table 6. A minimum 3 samples of strand shall be taken at random from each reel of pre-stressing steel on site in presence of engineer. Reels on site shall only be accepted if relaxation values determined by tests are equal to or lower than specified relaxation class of BS 5896. Sample requirements and frequency for pre-stressing wire shall meet requirements of AWWAD 110 and ACI 372R. Technical details of proposed materials and equipment shall be submitted. Details of jack type and size shall be submitted to allow for clearances to be checked. Calibrated stress recording device shall be used. Design data contractor shall submit. Details of proposed grout mix design. We have to see what contractor has to submit. Details of proposed grout mix design. Proposed grout mix design. Tendon extension calculations, vent pipe spacing and location details, detailed execution and shop drawings, calculation notes. Other submittals contractor shall also submit curriculum vitae and experience record of supervisor proposed who have a minimum of 5 years experience in such a position. Safety procedures including warning signs, barricades and communication between different stressing locations, name of proposed and pre-stressing company, giving details of previous projects, storage and handling. Pre-stressing steel shall be stored on a pallets at least 30 mm above ground and be protected from contamination by wind-blown sand or rain. Pre-stressing stand shall be in coils in sufficiently large diameter to ensure that stand pays off straight. Again say, pre-stressing strand shall be in coils of sufficiently large diameter to ensure that strand pays off straight. Pre-stressing operation shall be carried out. Pre-stressing operation shall be carried out only under direction of an experienced and competent supervisor, and all personnel operating stressing equipment shall have been properly trained in its use. Pre-stressing operation shall be carried out only under direction of an experienced and competent supervisor, and personnel operating stressing equipment shall have been properly trained in its use. In addition to normal precautions against accidents, it should be taken at all times for whole works. Special care shall be taken when working with or near tendons which have been tensioned or are in process of being tensioned. System of pre-stressing used shall be a system approved by engineer. Such system shall be used strictly in accordance with recommendations of system manufacturer. Under no circumstances shall equipment be of fittings designed for use with one system of pre-stressing be used in conjunction with equipment and fittings designed for use with another system. Pre-stressing components shall be stored in clear, dry conditions, shall be clean and free from loose rust and loose mill scale at time of fixing in position, and subsequent concreting. A slight rusting of steel, which can be removed by moderate rubbing, is acceptable. A slight rusting of steel, which can be removed by moderate rubbing, is acceptable, but surface shall not show signs of pitting. Wires and strands. All pre-stressing strands shall be 7 wire super stabilized low relaxing strands. 7 wire super stabilized low relaxation strands with a guaranteed ultimate tensile strength GUTS, guaranteed ultimate tensile strength of not less than 1770 MPa, 70 approximately kilogram per centimeter square, complying with BS 5896 or relevant ASTM standard. All pre-stressing wire shall be cold drawn high carbon wire, meeting requirements of ASTM 821 A821M. All pre-stressing wires shall be cold drawn high carbon wire meeting requirements of ASTM type B, having a minimum ultimate tensile strength of 1448 MPa. Prior to galvanizing, zinc coating for galvanizing shall meet requirements of ASTM A641M with a minimum weight per unit area of uncoated wire surface of 259 gram per meter square, with a minimum weight per unit area of uncoated wire surface of 259 gram per meter square. Minimum ultimate strength of wire after galvanizing shall be no less than 1241 MPa. All wires or strands to be stressed at same time. Shall be taken from same parcel. Coil numbers of steel used for each tendon shall be recorded. Welding of tendons shall not be permitted. All cutting of strands shall be carried out using a high-speed abrasive cutting wheel or friction saw at not less than 1 diameter from anchor. Cutting shall effect only after contractor has submitted stressing records and engineer has approved them in writing. Flame cutting shall not be permitted. Tendons shall be built into works strictly in accordance with system which is being employed. Tendons shall be built into works strictly in accordance with system that is being employed. Sufficient strand shall project from anchorage to allow jacking. Sufficient strand shall project from anchorage to allow jacking to take effect at stressing end of tendon. Tendons, you can say cable tendons or individual strands comprising cable shall not be kinked or bent. No sheaths shall be accurately located both vertically and horizontally as described in specific project specification. Unless otherwise described in specific project records or specification, tolerance in location of center line of sheath shall be within plus minus 5 mm. All sheath and cores shall be maintained in their correct positions during placing of concrete. Unless otherwise agreed with engineer, sheath shall be rigidly supported. Unless otherwise agreed with engineer, sheath shall be rigidly supported at points not less than 50 mm and not more than 500 mm apart. Method of supporting shall be to approval of engineers. Where sheaths are used, number of joints shall be kept to a minimum, and sleeve connectors shall be used to join for joining. Sleeve connectors shall be used for joining. Each joint shall be adequately sealed against ingress of material. Joints in adjacent sheaths shall be staggered by at least 300 mm. Joints in adjacent sheaths shall be staggered by at least 300 mm. Sheaths shall be kept free of matter detrimental to bond between grout and sheath. And except for material sealing, a sheath joint between sheath and concrete. Within 24 hours of concrete being placed, contractor shall satisfy engineer that tendons are free to move. Within 24 hours of concrete being placed, contractor shall satisfy engineer that tendons are free to move. If they are in ducts or the ducts are free from obstruction. Number and position of grout vents for entry. Number and position of grout vents for entry and outlet points, and for checking that entire length of duct has been adequately grouted shall be agreed with engineers before ducts are formed. Number and position of grout vents for entry and outlet points, and for checking that entire length of duct has been adequately grouted shall be agreed. Profile to allow disposal of water that may have collected as a result of rain or covering. For example, vents shall be sealed before grouting operation begins. Anchorages and blocks and plates shall be positioned and maintained in position during concreting, so that center line of duct passes axially through anchorage assembly. Anchorage and blocks and plates shall be positioned and maintained in position during concreting, so that and center line of duct passes axially through anchorage assembly. All bearing surfaces shall be cleaned before concreting and tensioning. Anchorage of pre-stressing wires shall meet requirements of AWWAD 110 and ACI 372R. Jacking equipment. Jacks. All jacking equipment used for stressing operations shall be of type applicable to system adopted. Jack and pumps shall be calibrated at an independent facility in presence of engineers before beginning stressing operations. Calibration of equipment shall affect at 6-month intervals. Calibration of equipment shall affect at 6 months intervals for equipment permanently present on site. Whenever new equipment is brought to site, equipment is removed and returned or serviced. Recalibration of equipment as described shall be required. All gauges, load cells, dynamometers and other devices used for measurement shall have a reading accuracy of within plus minus 2%. all gauges, load cells, dynamometers, and other devices used for measurement shall have a reading accuracy of within plus minus 2%. Stressing equipment for pre-stressing wires shall meet requirements. Contractor shall submit details of proposed stressing loads and stressing sequence to engineer for approval. Tensioning shall be carried out only in presence of engineer or its representative unless permission has been granted to contrary. Contractor shall ensure that personnel carrying out stressing are provided with particulars of required tension, loads, order of stressing and extensions. Immediately before tensioning, contractor shall prove that all tendons are free to move between jacking points. Unless otherwise permitted in contract, concrete shall not be stressed until it has reached at least age at which two test cubes taken from it attain specified transfer strength. Unless otherwise permitted in contract, concrete shall not be stressed until it has reached at least age at which two test cubes taken from it attain specified transfer strength. Cubes shall be made and tested as described BS 1881, BSEN 12350, BSEN, etc. There. They shall be cured in similar conditions to concrete to which they relate to and in manner approved by engineers. These shall be cured in similar conditions to concrete in which they relate to and in manner approved by engineers. Again I say, they shall be cured in similar conditions to concrete to which they relate to and manner approved by engineers. Friction factors assumed for calculations of tendon extensions shall be verified by on-site measurement of force extension relationship of a typical sample of installed tendons. Contractor shall establish datum point for measuring extension and jack pressure to satisfaction of engineer. Contractor shall establish datum point for measuring extension and jack pressure to satisfaction of engineer. Tendons shall be stressed at a gradual and steady state until they attain force required. Maximum force exerted on shall not exceed 75%. Maximum force exerted on shall not exceed 75% of ultimate tensile strength. Gross ultimate tensile strength. For purposes of cable detensioning, where installed stent has to be discarded, jacking force may be increased to 80% of GUTS. The force in tendons shall be obtained from readings on load cell or pressure gauge and extension of tendons measured. Two readings shall conform to limits set by engineer, but in all cases, force in tendon as computed from extension measurement shall be within plus 5% to minus 2% of force indicated by gauging system. When stressing from one end only, pull in at dead end shall be accurately measured and appropriate allowance made in measured extension at live end. If calculated and measured extensions vary from each other, by more than plus minus 6%, corrective action shall be taken. This may involve detensioning and retensioning of tendons if required by engineer. When required force, including overloads of short duration, has been applied, when required force, including overloads of short duration, has been applied to satisfaction of engineer, tendon shall be anchored. When required force, including overloads of short duration, has been applied to satisfaction of engineer, tendon shall be anchored. Jack pressure shall then be relieved in such a way as to avoid shock to anchorage or tendons. A pull-in of tendons at completion of anchoring is greater. A pull-in of tendons at completion of anchoring is greater than acceptable to engineer. Engineer may direct that force in whatever tendon be tested, any tendon be tested by rejacking. This will only be instructed if there is doubt that a calibration of tensioning equipment is accurate. Care shall be exercised by contractor during retensioning to ensure that jacking load does not exceed more than 80% of GUTS of strand. If it is necessary to crop tendon to enable duct to be grouted, this shall be delayed as long as practicable up to time of grouting. In all other cases, unless otherwise agreed with the engineer, tendon shall not be cropped less than 3 days after grouting. Contractor shall keep full records of all tensioning operations, including measured extensions, pressure gauge or load cell readings, and amount of pull in at each anchorage. Copies of these records on suitable forms shall be supplied to engineer within 24 hours of each tensioning operation. Tensioning pre-stressing wires shall meet requirements as said. Grouting. Grouting, we take up testing of water retaining structures, so we'll take up this a little later because it's a very important point here. We are talking of concrete specifications and we are talking of something which is very this tensioning system, jack equipment, anchorages, sheath cores and ducts, wires and strands, and pre-stressing. We have to, in fact, understand these facts clearly, and really it's not that easy as we think it is, and we have to consider these facts very smartly in a way that it doesn't harm us. And we can say that also it's an important fact what is done in engineering, particularly in concrete. We cannot take it for granted. As is said, you may say, certainly, because what do I understand by this? concrete is very important, and it's not talking pre-stress concrete. That's much more important, also very professional, very technical, and it may not be taken for granted at all. It cannot be taken for granted because it's a very important part of engineering and works, and we may say that a very important part it is, and we cannot take it for granted in any way, in whatever way. I wanted people to know importance of quality, and that's why here I'm trying to share with you particularly specification of Qatar, particular specification of Qatar, and I can't say that it's something you can say ignorable. It's not ignorable, it's very important one. It's very, very important one from every point of view, and that's what we have to really realize this fact. It can't be, you cannot say it can be, it can't be done otherwise. Until we think of quality, we cannot do anything otherwise. It's a very important point. If we want to think of quality, we have to think of quality. If we don't want to think of quality, we cannot think quality. It's in our hands. It's not in hands of somebody else. People may joke, people may not joke, that is different. People may say talking quality all the time, sick of quality mind, they may say. But because I think it's a major deficiency in engineering world nowadays, it's very important to correct it. And who can correct it, that is a question mark. Only we have to correct it, otherwise we cannot correct it. And that's a very important point here. We have to correct it, no one else can correct it. We have to check ourselves, nobody can check on us. After all, it is engineering, and engineering is based on facts. It's never based on fictions. This point we have to understand. Only profession with facts are more important than fiction, and that is engineering, and particularly civil engineering, where even modifications are not easy. It's not IT engineering where every day you can say I change this and change that and update. No update is permissible in this. It's very important fact required here. No update is permissible, and that's where we have to stand clearly. How can we say that? Very, very serious issue. It cannot be taken just in laughing stock. It cannot be designed as well as such. We have to be very serious, very careful with this. Only then we can say, okay, fine, we have done it. And that's an important fact we have to be very careful about. Sometimes people say something which is not correct, which is not factual. It doesn't happen, but doesn't happen. We have to understand that fact. How does it work? That's a very important point. We have to be very clear. I am very serious about this, though I'm not that level of engineer who can do everything self, but experience has taught me something which people are not serious about. Experience of various sections, various countries, experience of various, world level engineers, working with them. I'm lucky to work with many, many world level engineers, and that really counts, It counts in many ways. It doesn't count in one way or other way. It counts in many ways, and that's really important one. I respect them because of their work and because of their dedication, not because they are world people. They are so serious. They consider everything seriously, and that's where we can say it's important. World level is something different and cannot be taken for granted. We cannot take that for granted. It's so important fact. And that's what we are talking here. Experience based on world level. Engineering is very important. Very, very important, you can say. You know how people consider engineering, how people consider works very seriously. They don't enjoy, they enjoy quality, and that's a fact. They enjoy quality, and that is important everywhere. If you enjoy quality, you can enjoy everything. And they like it. They teach it, and they try to that more and more on that, which I don't know what happens to us here, why we're not that serious. We should be, but we are not. And that fact is really hard to understand. I can't understand that fact. Maybe you people understand better than me. I have no answer to that, but you may or may not may. It's really very important scenario that we have to think of. We have to swim in quality again. Maybe in past we did that, but now we forgot that. That part is really very important one, and we have to think of that. If we can't do that, we can't do anything. And that's also true. We can't do anything, clearly speaking. We can't do anything in that manner. You should do. Why we can't do? That's a lot to be understood. Why we cannot do. That point we have to understand well. Until we understand that point, we cannot get rid of this, and we'll continue to produce dirty material, dirty work, rubbish work, you can say. I've seen many activities here, infrastructural activities or building activities. You can say ultimately it is work. It is work, and we have to be serious about this. But we are not. Unfortunately, we are not. And that's where I say, I'm here to talk to you. I'm not your director, I'm not your mentor. I'm just trying to express myself, what I feel about. And that's where I say, I express myself, what I feel about. And that's where some people don't like it, no problem to me. It's not in some people's interest. It's the interest of nation, it's the interest of engineering. And that's where we should think of. Everything cannot be taken for granted. Nothing can be taken for granted here. And it's really interesting one to sometimes note like that. What we'll do, we have to do, we do. What we don't have to do, we don't have to do. And again I say, don't take it otherwise. I'm a serious person in work, not otherwise. Don't think of my face, how my face says. Our face is something different, but your intention is very important. That intention is very important. It should be like that. Without intention, we cannot do anything, and without something to be done that way, we can say what to do, what not to do. It's different work, different part, and we have to see differently. Engineering, again I say, quality engineering is not a discipline, it's a discipline among every discipline. You cannot say that it is a separate discipline. No, it's not. Quality is not a separate discipline, it's a discipline among disciplines. It's a part of every discipline. This point we have to realize, we have to understand, and if we cannot understand, then we cannot understand everything. That must be continuously understood, and if we cannot understand, then I think we can understand nothing, and that's where we fail. And our failure should not be justified. It should be taken action of. You can't justify your actions by some excuses, through some excuses. You can't say, I didn't have this system, I didn't have that system, and that's why I failed. That is not acceptable. That is not acceptable, I would say. Not at all. You cannot say, I could not get this because of this reason. That is not acceptable. Again I say, that is not acceptable. We have to take responsibility of our acts, and that's where requirement stands. If we cannot take responsibility ourselves, what to say about that? That is astonishing. You cannot simply jump on just coming after university. I am this. Don't say that I am this. Say I am a learner. I have to learn everything, and that learning is not only designs, that comes from works, that comes from field. And if you are not interested in that, then you can't be called a professional. I won't call you professional. At my level, maybe you are very smart guy, but a smart guy doesn't mean you are experienced one, Ask your seniors how they feel. Do they feel as you feel? That is important point. Life teaches means experience teaches. And experience teaches means you have to learn. And experience is very important from every viewpoint. If you don't have experience, you have nothing. Engineering is based on experience. Experience always leads theory. Experience always leads, life of an engineer. University destination is different. University destination is different. It is late destination. First destination is site. First destination is work. And that's where we have to be careful about. It's not because I'm just trying to speak something. I'm speaking based on my experience, based reality. What we do, what we don't do means I have to be, again I say, engineering is seriousness. Seriousness of mind, not seriousness of face. Whatever we do, we should do with confidence. We should with proven track records, our own track records. We cannot simply all time do something and then somebody should check it. Yes, somebody would check it, that is true, but it is what you have done. You check yourself first. This is quality system. If you do not know something, you don't do it. That's where point lies in. You don't do something if you don't know. Why do something then? That's where point lies in. Well, I would say it's good enough that we have done it. We have gone through this talk successfully, and I think it's better for us. We continue like that to know more and more about this. Talks can never be completed, but must be streamlined, and that streamline is required here. That streamline is required there. There's no other way. Otherwise, I will take a look here and I will try to sit now for next time. I'm going to close it for next time, and of course, because I'm lucky at least that there was no cheating. I will be back to you on quality system next time. Until that time, I will say, okay, thank you very much.